Now, this particular project has spanned well over a decade, probably going into 2. It actually has 3 different iterations of it. It started out in the very beginning as an alternate to hanging sausage from the reloading room shelves and just letting the air get to it to dehydrate. I thought, well, that's inefficient on small caliber sausages and meat sticks, so why not make a little dehydrator? And I just kind of did it with kind of some common parts. It started out with basically a 20-gallon rubbish bin with a top outdoor galvanized tank, and we took, here's a bolt, actually one of them, the old bolt, 1/2-inch bolt, drill 4 holes in the bottom for feet, put a nut on the bottom, put a washer, put that through the bottom of the garbage pail, put another washer and a nut on top, and that made its little legs, 4 little legs. Then I made it, of course, run off of electricity, used the extension cord, cut the female end off the extension cord, took it into the bottom of a switch box, looked something like this little handy box size. On the bottom, took the center, and I'll show you pictures of this, but it's already been modified, none left that exists today of what it was before this most recent modification. So took a boxer fan, a computer fan, a 120 volt boxer fan, and right in the center of the bottom cut a hole in the bottom of the pail. It had legs so it would stand up off of the ground and give it a little bit of air to come up. Put that boxer fan in the middle of it, bug screen or finger screen on the bottom, screwed down, pinched in between that and the bottom of the garbage can, put one on top of it because it just needed to pull air through the bottom of the box, pushing it upwards. And the lid I used, I'll show you a picture of it, it's just several holes. I calculated the size. I wanted more area up at the top than at the bottom. Calculate even pattern and put some on inner ring, outer ring, because I wanted the air to flow up, go around the sausage to the outside. Worked pretty good as a dehydrator for years. I did at some point pretty quickly on add 2 4 and 11/16 extension rings and sat down over top of that boxer fan, and the very top of it, I had to use 2 of them to get it high enough, the very top of it, then put a plate, put a ceramic light base up there so that I could run light bulb. And this dates back before Hillary Clinton and the Democrats decided that we should not be able to have the old Edison light bulb, the incandescent. And so if I needed just a little bit of heat, say in the summertime, I could either unscrew the light bulb or add like a 25 watt bulb, or if it's a little bit later, 40 watts, 60 watt, 90 watts, 150, 100 watts, 150 watt, and that's how I kind of controlled the heat. Up at the very top of it, I put a safety kick out just in case something bad happens, and I'll show you a picture of where it used to be from a still frame from a video. We'll show you that. And basically that's all it did. It just, you flipped the switch on the outside and it ran air into it. Well, how did we get it wired? Well, we took one of these boxes and we had, with a switch in it, we had it at the bottom, brought the power in the bottom with the cable, went through it with a piece of conduit back to the 4 and 11/16 box. You'll see a picture. It'll make good sense as soon as you see it. And then we went up from the top up to the top box, which actually is this one, which is actually an extension ring, because this set around that upper thermostat, because the upper thermostat, the safety, the 140 degree cutout thermostat was just there in case something ever went hog wild, okay? Because it's just running a light bulb. That's all the heat source, just enough to raise the heat. And you would say, well, why did you want to do that? Well, because relative humidity. The hotter air is, the more moisture it will hold. So if I have an ambient situation at around 70 degrees or 60 degrees, the amount of moisture in the air is still there when I take that same exact air and heat it to 100 degrees. But the relative humidity takes a nosedive. And when the relative humidity dives down, that makes the air drier. and then the moisture inside your sausage is then wetter, so it wants to come out and everything equalized out, so it dries a little bit faster without really like cooking it, so to speak. And it worked by using the magic of the Edison light bulb. Genius, right? Farmers have been put light bulbs in well houses and hot boxes to keep them from burning up. Construction workers, we used to heat up your what do you call it, SpaghettiOs with one of those. Or if you couldn't set it on your engine block, you could set it right in a box, just light bulb, heated up by lunchtime. So that's all that was, until we had to modify it, and we decided, well, what if I want to make a little better airflow pattern and a little bit better temperature regulation? We'll make it into a proofer. So it goes from a dehydrator or a dryer to sort of a proofer that I could control the heat with. But its base design was still always going to pull air in through the bottom and through the unit, so it doesn't recirculate any of it. So moisture would be an issue. So you don't put anything in there for any length of time. It's just there to basically start dehydrating and keep it at a higher elevation. And we made that modification not too long ago. I've got some video of that we'll piece together, and I'll show you how that works, because we also insulated, did some other thing, added a digital controller, didn't cost much to it. We'll add that in, and I'll cut you those little pieces in there. And then this very last modification has to do with the operation of it, where I turned it from a turn to switch, and it works strictly off of the controller up top, and run air through it at all time, to where I could either run it with airflow through all the time and temperature regulation, or run air through it and then turn the fan off when it gets up to set point, so it just kind of heats up and stops, and then heats up and stops. It's a little different purpose. With that, I could actually do some smoking with it. If I put some smoke, some chips, some hickory chips I cut off of actually a limb or a piece of hickory, it will smoke for quite a while. But with the air flowing through it at all times, as soon as I turned the heat off, once it was smoldering, it just continued to smolder and continued to burn till it burned up that piece of wood, and we ended up with some thermal overshoot. So to make it smoke a little bit better, what we did is we made it where we could flip that switch in the other direction, and it would just heat up, and when it got happy on the thermostat setting, it would cut off and then cut the smoke off, and eventually the embers would die down and it would get cool, and we could come back on and run again. So it actually regulated out much better. As just a heated box, it works pretty good. It's a dry box. It's not a wet box. So it's not something you would use for a long period of time, because again, what was it initially? A dehydrator. So let's watch a little bit of video. Now this video is what remains a video shot during the COVID period, when I rebuilt this into a proofer from just the dehydrator. And what we did there was we added a digital controller so that we could better actually control an operating point rather than just simply dehydrating it. We wanted a certain point to proof at. And we took the bimetallic thermodisc style, the Selco 140 degree thermostat off the wall, and put it down there where the heat was, to protect the wires, because I built a plenum or a stack center of the rubbish bin so that the air would come up through it, come out and run around the sausage and go up through the top. We also insulated the entire can, and to do that we had to reinforce the bottom, because when we put very tall bolts in there, it was a little wobbly. So we had to reinforce it with a little bit of metal stud track, and that's what you're getting ready to see. I'm gonna piece all this together, and we'll come back, maybe do a flyover at the very end. Now I'm getting ready to put this reinforcement. I made a piece of almost like a caster plate to reinforce the bottom, because, and this is just kind of rough cut track, sheetrock track. I don't know what gauge this is, pretty sturdy. But I'll get that lined out and I'll shoot it down, probably use a little VHB tape and a little silicone underneath. Probably run some temporary screws in the corners so that I can come back from the inside and drill out the base.
where the peg leg holes go. But this will give me something to allow the insulation to go across to about here, and then when I bring that edge down and tape it, it'll help keep the insulation at a uniform thickness.
Now I still need to wire it, so I had to unwire it before I could wire it. And you remember this little box right here. Okay, now we had these little handy box side. This was the top one, and it's actually a extension ring because we used it to fit over that thermodisc, actually the Selco brand 140 degree bimetallic disc thermostat. It actually had leads come out, so this was put over that on the side of the can, and the little round hat on the thermostat went through, had a little hole, and it went through the wall of the bin, the can, so that the air would be able to hit it, and if it got too hot, 140 degrees, it would kick it off. Okay, but we need to take this off because we wanted to replace it with, I think it's a Carlon brand, 4x4x4, a little plastic junction box, and I had to cut a hole in the lid to put the Inkbird controller in, and that's what we used to put it in. So we put that up there, but on the back side where we had our thermostat coming through, we opened that up so that it took a 1/2-inch piece of conduit, ran a chase nipple through that, and on the other side did something I thought was pretty ingenious. I took a end cap for a piece of white PVC plastic and where it would screw on from the inside. Of course, it had a hole drilled through it, so I could take that RTD, that Inkbird RTD, and run it through that white piece of end, the little end cap, and then filled it in with a modeling glue, a cyanoacrylate model glue. And if you don't know this, you can fill it up. It's the thick stuff. If you fill around it, then you can dump some baking soda on it, and it will instantly harden. And you can wash that out, kind of dry it out, put you another little layer, put some more baking soda on, and you can build up, kind of fill up that piece so that resistor that doesn't want to flop around, so it actually makes a little piece. And I'll show you when we do the flyover what it looks like on the other side. But remember, we're taking off the thermodisc and replacing a plastic box on top of it. So I mount that down over that space and then drill out through both pieces, the plastic box and the garbage can, so that I can run a chase nipple through, and then that piece, and that's how the wiring goes. And I'll show you that in just a second.
And you see, it's just a through hole that we've cut for the 1/2-inch chase nipple. And you see, of course, a rivet up at the top. I need to grind down a little bit more and put a little silicone around, keep the germs out. I'll fill these heads the same way. They are slotted, so they can be brushed out. But the remaining hole you see below and above are part of what remains from when there was a thermostat in this position to monitor the air temperature that way. So we're just going to kind of deburr that hole just a little bit more, clean it up, and put the chase nipple from the controller side and the white piece with the sensor in it from the inside. To help focus this, I did get this old shop rag out. It's a little stained. I don't know how much. It doesn't look too dirty on the monitor, but it is. It's old and it's stained, but you might be able to see the cyanoacrylate's a thick compound. You can get it at hobby stores. It is essentially a super glue, but a thicker version of it, so you can mound it up around that cable on the inside. And this thing is called a chase nipple. Now, one-handed, I don't know if I'm going to be able to show this to you. You see, it's not perfect, but it fits in there. And from this side, fairly snug fit. And if I push it down, it does not have the clamps on it from the other side. But if I keep the shadow out, see, it fits.
It's not tight. There's a little bit of friction to it, but it's not bad. And that's about as good as I can do by hand. Okay, let's look just briefly at the wiring of the Inkbird, and this is whichever model that is, I forget, but it's attached, and we have the line and neutral coming in. You can see it's coming in from below, from where the switch is. We have line and neutral coming in here. We have the hot jumped over to the switch, and then we have the other side of the heating switch is this yellow and black. It's black wire with yellow stripe on it. Goes down toward the switch where it goes into the unit below. And of course we have the sensor here, which is coming out. And see if I can get enough light on it. You might be able to see it. See the chase nipple in the back, what we've been talking about? Now I need to put the socket on top, but before I do, I thought I might try to peek in here if I can get the light just right. Okay, in this we have just the neutral tied together. We have the ground bonded here in the corner. We have the fan below with its upper, finger shield, keeps the wires from falling in there. And then we have the yellow wire, the yellow stripe. That is our light / heater, where we use an infrared heater. Comes over here to the Celco. That's a 140. Cuts out at 140, cuts back in at 110. It's the red wire. It goes to the light socket. And the fan, if I may come around to it, is the violet. When I first tape this down, I use aluminum tape, specifically around the inlet at the bottom, because it allows me to pull. It has great adhesion. It is UL listed for this application, which is insulation and ductwork. And it allows me to shape around the inlet hole, as you see right there. Now I can come back in with a little bit of white general purpose duct tape, the kind of cloth type, to kind of hide the fact that it's nice and shiny. And I'll do that, but just to make it look a little prettier and to maybe tighten up around the feet a little bit, some of the slices there. But it's very simple. And that tape is about $16 a roll if you're lucky to find it. Now here's the bottom all prettied up with the white duct tape. And you can see the inlet for the air coming in. Now the air comes in across the fan, blows over the top where the wires are, and then of course over the top of the heat source, which last night I used a 65 watt or maybe a 60 watt bulb and checked it since it was insulated to see what I was able to get out of it. And I was able to get, with a thermocouple at the bottom and thermometer at the top, I was able to get a 20-degree rise with a 60 watt bulb, incandescent, not a LED or anything goofy, actual old-fashioned light bulb. And the top, between the top and the bottom, I got a 20-degree rise over ambient with the bottom at 1 degree differential from the top. Now this is some of that video I have to recreate from what was lost, but here we see just some stainless steel quarter 20 screws here, socket head, and I filled them in with silicone because I'm going to use them for thumb screws. Because if I pull this off, this is the top of the little hat, and there is our little heating element, all pretty and everything. But I have 3 clips. If you'll see, there's a clip at the front, clip there, and on each side. And what that does is it allows me to put this
assembly, this cap on this is the top is drilled out. Like it's got two different size sets of holes in there. Just around the perimeter. It's a painted black. I've got it painted flat black inside to make it hot as it can get while still blowing the air through it. $99, $99.3, $100. That looks like 99. Well, let's take the wrap up. I will say right here we had the little floppy portable handles that go with the rubbish bin. I took them off before I wrapped it, as you see, because they were annoying and they really didn't have a good way to do them without them wanting to flop and go down, and that would tear the insulation. So I just use square U-bolts here and of course here, and it works just fine. Now we see the plenum top is put in, or what do you want to call it, the stack, and we have already looked at that, and there is our, if I get my arm down there, you can see our little thumb screw, so it can come on and off, and we're just done. I do have a little spring coil of copper to hopefully make it a little bit more sensitive, but you can see we can clean it out inside. You see these little stripes. These are actually from where it sweat a little bit while it was in a smoking mode. Now, how would you use this? Okay, we now have our double pole, double throw, center off switch there. And you see I've just temporarily put a P for proof and an S for smoke. And of course we have it right here. We have our little ink bird there. And it looks like it's a little bit crooked, although I thought I had it straight when I made it. So, what are the three modes? Well, let's start with the proof mode, which is the one we just made. We turn it on. We come on, and it's going to heat up, and the fan is going to run constantly, 24/7, 365. And of course, the air is going to suck in under the bottom, come up through it, and come out the top. And of course, there's our little controller, and you see it's calling for heat, so we're making heat inside. And if we do the set point, just push and hold set point. Now it says thermal set, I guess what that's for. It says it's for 90 degrees. And I'll go ahead and make that go away without any change. Set it right there. So it's 70 degrees. So it's calling for heat. So we've got both fan and the heater going. Now if I were to take this and take the set point, hit it again and run it down to say 70 degrees, I'll be able to demonstrate my next point. Alright, now we're on proof, so you still hear the fan running and you can see it's calling for cool. So that's how we know that it's working properly, and we've got air running all the time. Now if it's in smoke mode, if we kept blowing air across the wood that's smoldering, it just keeps on getting hotter and hotter in there. So we have a different mode, center off. And when I put it to the S, we're still running up here, you see. But we've got no smoke. If we were smoking, we'd still be smoking as we kind of died down without that air blowing across it. But to prove that it would work turn the fan back on with the controller, with the Inkbird, let's go ahead and open that back up. Let's run that back to 90 degrees. And when we set it, we hear the fan come back on. You hear it spin up? Now, if you wanted to run it in just dehydrator mode, just ambient air. Remember, we're pulling air under and through, and it pushes it around the sausage and up out of the top. All you need to do is just push and hold the power button, and it turns that off. But we would have to be in proof mode. So what do you think about that? Okay, so there we are, wrapped up and ready to go. Just give you a rundown on those controls one more time. Air dryer mode, we don't really need heat, we just need fan all the time. In the proofer mode, we have fan and heat. We could run the Inkbird. So if we wanted to run just air dry, well, we just push the power button on the Inkbird, turn it off, and in proofer mode it would just run the fan all the time. If we throw it in the S mode or the smoke mode, which only developed out of the fact that if I kept blowing air over the smoldering chunk of wood that was in there, it just kept getting hotter and hotter and hotter because it kept wanting to burn. So smoke mode is just the fan and the heat running at the same time, and you will get a little bit of a little lump, a little thermal jump over there as that wood continues to smolder until eventually it slows back down. And then of course next time it needs some heat, it'll warm back up. So you can play with that if you want, see what it does. And I guess that's it. Wait, you say what? I didn't show you a wiring diagram? Okay, well, I'll throw one in here pretty quick. It's pretty straightforward. All right, look at this right here. Now, I haven't shown ground, but you know, you attach your ground. I showed you in the video that there was an internal ground wire there at the 4 11/16 boxes. There's another one should be on the inside on the switch box itself where the switch is. And of course, it's just not shown. So the green wire is just helping me understand. It's not really green, it's just I use different color of highlighters just to chase me down to make sure I didn't cross anything up. So neutral is connected to everything. It's connected to the heater base, it's connected to the fan base, it's connected to the Inkbird. So that's just it. Now the power, the line power comes up. I've shown it in orange here just as I trace it out. It goes to the terminals on the bottom of the switch. This matches this particular switch that I have. So it comes in, jumps to both sides. So as you can see that bottom wiper, when it's either left or right, it's always giving power through that black wire to the Inkbird. And so the Inkbird always has power jumped around the back to that heating contact. So whenever the Inkbird is on, it has power to run the heating element as it sees fit. And I just ran that heating element wire back down to the other side of that switch. So if we go to the wiper left of the upper switch, we see the fan will run all the time because it's tied to power. As long as it's plugged in the wall, it's going to have power, the fan is going to run. If I switch the wiper to the other position where the little red is, what it's going to actually do is it's going to come off. It's going to only get power when the Inkbird turns that contactor on. So the fan and the heating element will run together. All right, so that's it. I hope you have a great rest of the day. And you know, if I were to change anything at all on this, I'd probably just get a bigger box. Because when I started this, I was only doing very small sausage and meat sticks, that type of thing. That I just wanted to speed up just a little bit quicker and keep it, you know, kind of in a container rather than just have it hanging from the shelf in the reloading room. So, all right, well, we appreciate you. If you will, please do me a favor. YouTube, I know this is a long video, but YouTube, I'm not sure I'm getting credit for all my views and all my subscriptions. So if you will, the way that big business works is it's all about the numbers. And if you will, if you like this kind of stuff that you don't normally see a lot, now it's kind of random, I know, but if you like this kind of stuff, I need you to subscribe. And I need you to give me some thumbs up from time, or whatever they call it, likes, or leave me some comments, because they look at that activity when making their decisions. And hey, I'm sort of freeloading off of their server, so I need to show that I have some value to you guys and to them. So appreciate you watching. Please
subscribe, tell your friends, get everybody watching. Can't hurt. I know I run long sometime, but I do things a little bit different than a lot of these people who are trying to be TV stars on YouTube. I'm just trying to show you something, get your mind working, come up with your own inventions. Appreciate you watching.